All right, perfect. So, hey everyone, my name's Tim. I'm a member of the Bishop Fox Red team and one of the developers working on Sliver. For those that missed last session, Sliver is an open source C2 that we share with the community, and we thought we'd do a few webcasts to walk through some of the newer features, as well as some of the features that we've rebuilt as part of this upcoming release. I've shared a link to the newish documentation website we have. We've also included a tutorial that I've written. It's something that I used to give at conferences, so we're trying to give it in a different format here. It's work along type of workshop. So I'll be doing all the demos live here on the webcast and answering any questions that you might have, and then feel free to go through the recording if you're not able to follow as we go through these. As I mentioned before, last time around, we covered beacons and sessions. We went over the different C2 profile options that existed, and we kind of touched on payload staging. So we'll start by redoing that demo, and then we'll move on to pivots. So this time around, I've actually prepared a lab. So we have a small Active Directory with a couple implants running, which we'll be using for this. So let's quickly switch to my Sliver server. If we go ahead and tap implants, we can see we already have a few builds ready to go, mostly for Windows systems. One of the newer commands we have here is a subcommand of implants called implant stage, which will allow you to expose an implant over the existing listeners. If I type the jobs command, you should see three listeners here, HTTP and HTTPS. You no longer need to have a separate stage listener like that used to be in previous releases. Instead, everything is exposed through the existing listeners now. So if you type the implant stage command, you get a list of all implant builds that exist in the Sliver server. And say, for example, I want to stage this particular one, I can just go ahead and select it. If I now type implants, we can see the stage field here is set to true, and it now has an ID, which we'll be using to access that particular implant. So my Sliver server is hosted at this IP, so 10.0.0.5. And then to actually access any individual implant, all you need to do is have a URL parameter, for example, I or really any random letter will work, followed by the ID. Now, you can break up that ID with letters if you want to. The only real thing that matters in here is the actual numbers in the ID. The rest is just ignored. So if we go ahead and copy that over and then switch to my Windows VM, if I set up a quick curl command in PowerShell and just output this to http.exe. Oh, that's just great. Oh yeah, sorry, http. You can see it's downloading our file and just writing it to disk. And as soon as it's done with this, we can use the implant stage command to, again, stop staging that file and kind of dynamically control which files are exposed by our listeners as we need them. And we'll kind of go a bit more into how you could dynamically set which files are exposed when we go through the scripting portion of the workshop. But this is one of the demos that we couldn't run last time around. So just quickly wanted to circle back and go through that. So if we look at sessions, I already have one implant running on a Windows, I think it's 10 desktop. Quickly go ahead and use that. And then if we type help, we can see, as previously mentioned, the list of all the commands that are available. The ones that interest us right now is the pivots command. If you type pivots, you'll see a list of all either TCP or named pipe listeners that exist on any particular session. So the way this is set up is you use this command to spin up a listener on an individual session, and then that session will relay all of the traffic from any implant connecting to it through that medium back to the Sliver server. And that way you can get network traffic from hosts that might not necessarily be as permissive from a network standpoint. If you can't get any outbound access, but you can get it on one specific host, you can use this to route traffic back and forth. So like I mentioned, there are two types of pivots, TCP and named pipe. The command line works the same way for both, so I'll just demonstrate the TCP one. But you can have examples of both of them right here on the documentation website. You can see there's a small video showing exactly what commands to run and how to run this. So let's talk about the TCP pivot. If I go ahead and type pivots TCP, it'll spin up a listener on that host. By default, it's on port 9898, but you can change that in the parameters if you wish. And that's pretty much all you need to do on the session side. From that point on, the next step is generating either a beacon or a session that can actually call back to that particular pivot. So we'll go ahead and generate a session that calls back over TCP. Quickly double checking the command. Yeah, here we go. So all you have to do is set a TCP pivot with the IP of the host that needs to connect back to, which in this case is 10.0.0.6. So the host our session is running on. You could also specify the port if you've set a custom one, which isn't the case here. And then we'll go ahead and just stage that implant. So if I had implant stage for the session that we just generated. Yeah, so if you type Control R, you'll get a list of previously run commands, and then you can just search through it. So if I type generate, for example, it shows previously used commands. I'll try and keep an eye on the chat, but if I miss something, I'll get back to it later on. So we've just generated our implant, and it should be accessible through our listener. If we take a quick look here, let's see. Yeah, right here. ID is 18955. So I'll switch back to my Windows VM, and we'll go ahead and quickly retrieve that. Now, this is just for demonstration purposes. You could very well stage this in different manners. Let's say, for example, that you're copying the binary over SMB on a share somewhere and spinning up a service to run it. It would be pretty much the same process. I'm just downloading it here for convenience purpose so we can quickly run through this. So if I double click this, since I build it, I believe in debug mode. Yeah, it'll spin up a window and it'll show the pivot key exchange. And as you can see here, it successfully negotiated the key exchange and connected back. And we now have a new session. If you type in session, let's see. So if we go back to our initial beacon, so the distant wax one, and we type pivots, there are a couple additional subcommands here we can use, like pivots details, for example, or pivots graph to review the currently negotiated sessions that are transiting through that particular listener. So what you're seeing here, for example, is a child session, which is connecting back through our parent session here and then getting back to our Sliver server. And so any commands that you run in that child session will be retrieved first by our beacon calling back over HTTP and then transmitted when that TCP session will calls back to the session in the middle, if that makes sense. The way all of that is set up is using a mix of public-private key pairs and hard-coded keys. Essentially, there's a key exchange that happens when the session tries to initially set up. If I move back here, you can see the first few messages here are around setting up that key exchange. What's happening in the background is our implant is calling back to our intermediary implant with an initial session setup packet, and then they do a key exchange to switch to public-private cryptography. And then from there, all of the packets that are sent by our TCP session will be sent to our intermediary session where they will be unpacked, but not unencrypted, and then sent to the server, which will then unencrypt them and actually be able to access the content. So any nodes in the middle of that traffic won't actually be able to see what is going through. They'll just be able to confirm that this is a valid Sliver packet and relay it wherever it needs to be relayed. And this way we can limit what information is visible at any node in the network, so to say. So if there's any particular logging that's a bit more in depth, like for example, if you have memory dumps in one particular host you're routing through, it's a bit less of an issue. It's still possible to retrieve plain text, but it's less likely to happen. You'd need to really start reversing the binary manually to extract the keys instead of just being able to grab a dump and see the plain text protobuf messages going through. Yeah, and you can pretty much chain these as you go along. I could go in my TCP session and create a new TCP listener and then have another beacon route through that. The goal is really to allow you to build your sort of custom networks routing traffic through your environments as is needed. So this is for TCP pivots. SMB name pipe pivots work in the same manner. You just spin up a listener in an individual session, and then you generate a beacon using that particular name pipe, and then you have all the traffic routing from that name pipe to a HTTP, DNS, or whatever session that you've set up, relaying that traffic, which then goes back to our Sliver server. Now, I know that's a lot to go through, so if there's any questions, throw them in the chat. Happy to answer anything. Otherwise, we'll move on to the main part of today's workshop, which is around automation. So, going back to our main menu, one command that we haven't really talked a lot about yet is reactions. Reactions are a basic automation feature that we've set up in the Golang CLI itself. It allows you to specify commands that can run based on certain events. And what I mean by that is, if we just take a quick look at the reaction help, you'll see something called reactable events. When these events occur, you have the opportunity to tell the framework, okay, when this event happens, run these commands. And that is all reactions is. It's still the exact same commands that you have access to in the CLI. This really just allows you to automate things like, for example, if you have, I don't know, a new beacon connecting in and you want to automatically dump environment variables, you could just use a reaction to do that. So we'll go ahead and run through that demo. If I type in reaction set, that's the command to create a new reaction. Tag E, and then I need to give it the event I want to react on. In this case, I'll just react on session-connected, which is fired every time a new session connects back to our Sliver server. So if we hit enter here, we then get this UI that tells us enter commands, and we can enter whatever commands we wanted to run at this point. So let's say I want to run pwd and I want to run env. Then enter 2 blank lines, and we have our reaction ready to go. If you tap the reaction command, you can then see the ID of that reaction and the commands that are being run. So let's quickly stage an HTTP implant and run it on our Windows host. So quickly download that. Cool. So if I now open up that session, we should be seeing the reaction fire, and there we go. We can see that it ran the pwd command first and then the env command. Now, by itself, reactions are a pretty basic feature. It's handy if you want to make sure you do certain tasks on every single beacon or session. But it's a bit limited in the sense that it doesn't allow you to do any filtering. For example, you can't specify that a reaction only run on a specific operating system type or on a specific callback type or anything like that. It'll just run it on any time. It'll just run it anytime any particular event fires. So it's the main reason why we also have what we call SliverPy, which is a Python client that we can use to send protobuf messages back and forth. So if we go back to the graph I had in chapter 1, looking at how all of this actually works together. So we have our Sliver server, Then we have our operator on the side, and we have implants running on a bunch of compromised hosts. All of these are talking back using various protocols, whether it's HTTPS, TCP, MTLS, whatever it may be. And then all of this is sending packets that are either encoded or encrypted in various ways back to the C2 server. And then the C2 server can access all of that, unpack it, unencrypt it, and read the underlying protobuf messages. All of these are essentially talking the same language. They're all encoding their data in protobuf messages. And so it's possible to write your own CLI or your own implant or whatever that just sends back those same protobuf messages to the server and receives back events from the server to perform tasks on. And so you're not necessarily constrained to the Sliver client CLI. You can essentially write your own interface to communicate using the same communication protocol. One option for that is a project called SliverPy, which is a Python implementation of the Sliver protobuf language, which allows you to create and send those packets interactively. I'll be doing today's demos using that project exclusively, and specifically the 1.6 branch of it. The current release one is for the Sliver release, so that would be 1.5 something. If you want to try this later on, there is a documentation website which is generated, so you'll most likely need to spend some time going through the source code manually for some of the more advanced tasks, but I'll go ahead and drop those in the chat in the meantime. But there are other implementations that exist, like for example, SliverScript, which is a TypeScript implementation, again, sending the same protobuf messages, just a different language. So if you prefer writing TypeScript, you could maybe use this project. Maybe you need to update a couple dependencies here and there, but that's the main idea of it. So I've prepared a few scripts here that we can use for as a demo. We'll start by quickly walking through the code so you can see what that looks like. Then we'll do interactive demos as we go along. So let's switch to VS Code. So here we have a very first script. The first thing you should be noticing is this here, which is the configuration file used by this SliverPy script. And to generate this, you need to be using what we call multiplayer mode. So if you notice in the jobs command I ran previously, we had a listener here for gRPC MTLS on Shibran 337. That's the multiplayer listener. So if you run this, it's going to spin up a listener on that port by default. And if we look at operators, we can see I already have an operator here called script, which is a user I created to run commands on that server. You can create your own using the new operator command. You just need to make sure that you give it the all permissions so it's able to properly interact with the Sliver server. There are other groups of permissions like builder and crack station. Those are for different features. For example, up till now, what you've seen me do is run all generate commands in my main Sliver server, but it's possible to actually offload all the builds on a separate server and have it connected back to our Sliver server. We might demo this in a later session, but just to explain, this is basically what these are for. And all is what you need to directly interact with implants running through that server. So moving back to VS Code. So the whole thing is written in async to be able to asynchronously respond to events as they happen. This particular example here does something pretty similar to what we've seen previously. It listens for the session-connected events, but this time it actually does something that's a bit more detailed in the sense that it does different actions based on the operating system of whichever session is calling back to. So every time we have a session connect event, the first thing that happens is it's checking the event.session.operating system, event.session.os, and then based on whether it matches either Darwin, Linux, Windows, whatever, it'll run different commands. Now this example here really just does a small print. I think for macOS I had a, yeah, maybe I can add this here also. Just runs a small command. It's pretty similar to what we had with reactions, but this allows you to fine-tune your commands a bit more. So let's go ahead and run our script. So we have our listener running. If we go back to our VM and we start our session. We should be seeing an event happen here. And yeah, we got the connection, and then we got the PWD command running. Now, you could tell me this is the same thing that was happened with reactions, but this is a bit more fine-tuned. For example, if you wanted to write a script that automatically deploys a backdoor on a host as it connects, you could now have that based on the operating system that's connecting back to. So for Linux, for example, you could add something to a .bashrc file, or for Windows, you could modify registry keys. Instead of having a generic reaction that fires the same commands for everything, you can now have something a bit more targeted. And that's going to be a bit of the theme of the different scripts that we're going to demo today. So that was the first one. The second one, task many. So this is based on a question that somebody asked in the chat last session around how to run commands on multiple beacons or sessions. There used to be a command in the CLI called task many that we've removed because similarly to reactions, it had some limitations which we weren't really happy with. So taskmany.py essentially does the same thing. You have the same preamble here where it parses the configuration file and connects back to our server. And then we actually have the code, the meat of the code of our script here. So what it does is it lists all of the sessions that are connected on our Sliver server, and then it iterates through those sessions. And for each session, it's going to do a quick check to see if that session checked back in the last 5 seconds. And then if it did, it'll run a command on that particular session. So this is not event-based. This is more of a connect to the server and run this command on all of these hosts. And again, you can filter this based on whatever you want, whether it's operating system, whether it's callback type. If you want to, for example, for some reason, run a command on all beacons calling back over DNS, this is how you would be able to do this. So in this case, again, it just retrieves the environment variables for all hosts and prints them. Now, in this case, again, if we go ahead and run that script, so taskmany.py. Oh yeah, sorry, I left some debug code in there. But basically, you run this, it iterates through all connected beacons or sessions, and it runs the end command. So it's nothing super fancy, but the idea is to give you building blocks for you to see what type of automation is possible, and then write your own scripts as you explore the framework. So we've talked about task many, and we've talked about the initial test. I do have one last one, which is again something that I've been asked about in a workshop I gave this year, which was around having some external logging for Sliver, right? Because sometimes you run social engineering campaigns, those can run over a couple of days, and you're not necessarily going to be in front of your keyboard all the time. So it'd be nice if you could have like automated alerts of events, like for example, when you have a new session pop up. So this is more or less what this script does. Again, we have the same basic preamble where we parse the config file and then we connect to our Sliver server. And then the next part here, we react on session tag connected events. And each time we have that particular event, we just send a Discord message to a custom channel that we have. So let me just quickly move my Discord window here. All right. So I've set up a separate server for this just for the purposes of this demo. All right, move this here. And our CLI. So first, we'll go ahead and run our discord.py script. So this is now waiting for connection events. If I now switch to my VM and I spin up a new session, if I go to Discord, we can now see we have a new message from my bot here. Yeah, so we have a new session. It prints out the session ID and the username. And you could pretty much run some additional automation on top of this. This is really just a very basic logger. You could very easily replace the Discord code with something hooked up to a phone number if you want to get an SMS or Slack or whatever your preference is. Cool. All right. quickly switching back here. Here we go. So this is how we do automation when we interact with Sliver. I've run through all of the demos I had prepared for today. So if there are any questions or anything you want me to delve into, feel free to drop them in the chat. Next time around, we'll be going through some of the more in-depth features that require some additional setup that we've included in Sliver, things like chisel, things like buffs and assemblies that are a bit more involved, and how the new armory setup works. And also how we can use Cursed Chrome to interact with browsers once we have access to user workstations. So thank you for attending this quick workshop. Hopefully I didn't go through everything too quick and it makes sense. I'll upload the scripts that I've showed on GitHub and I will drop the link on the Discord chat shortly after this talk. And as always, feel free to drop any questions either in the chat here or in the Sliver channel. I'll try to keep an eye out for anything that comes up. And yeah, thank you for joining this talk.